Good day, my dear wonderful grade 10s. Today we are here to talk about an interesting topic in physics, grade 10. It is electromagnetic radiation. Yes. So as I've taught in the past lessons that we have two types of wave, which is mechanical waves and what? And a type of wave that we call electromagnetic wave. Mechanical waves are those we already passed on, which is the longitudinal wave and the transverse wave. Yes. So now we come to the electromagnetic wave. These are the type of waves that do not require a medium to travel through. Yes. So the first and foremost, I would like to highlight this definition. Electromagnetic waves are disturbance that consist of oscillating electric and magnetic fields. Yes. And they can travel what? Through a vacuum. As you can hear, they do not travel through a medium, they travel through a vacuum. So there's a difference between what? The mechanical waves and the electromagnetic waves. So yes, I would like to introduce you to what we call an electromagnetic spectrum. So an electromagnetic spectrum is very important to know. The first and foremost, I would like to introduce you to what we call the radio waves. Yes. So radio waves consist of what? The longest wavelength and the lowest frequency. Yes. Let's go to this diagram on my right here. So as you can realize that what these are the radio waves. The radio waves have small or a lesser frequency. This is frequency, as you can see. This red line is frequency. They have lesser frequency, yes, but they have what? A larger or a longer wavelength. Yes. By the way, electromagnetic spectrum encompasses all types of electromagnetic radiation, but they are arranged by frequency and wavelength. Yes. So now we're going from longest frequency to what? To the shortest frequency. But then at the same time, we're going from lowest frequency to highest frequency. You get? So bear with me. Microwaves are the one used in ovens, as you know, and they can also be used for communication. So they have what? They also have a longer wavelength, but a shorter what? Frequency. As you can hear, as you can see here, this is still what? This is still a shorter frequency than expected. Going to visible light. Visible light is what? That is the portion of the spectrum that a human eye can detect or respond to foresight. Yes, as you know that light reflects on object. That is the only reason and the only way we can see things. Have you realized that when it's dark, when there's no light, your eyes cannot significantly see and they cannot significantly see what is opposed to them or what is in front of them, because of then there's no radiation, which is the sun, that is reflecting on top of those objects. Yes. So we have what we call ultraviolet radiation, which is the sun, as we all know. It is used in what? It is used in the process of energy. Yes. But then there is another topic for another day. So we also have X-rays. X-rays are used in medical imaging and industrial inspection. Then we also have what we call gamma rays. These have the highest frequency and energy, and are used for cancer treatment and sterilization. Is there coming to the uses of this electromagnetic spectrum? But then for now, I like you to befriend yourself with them and make sure that you're used to them. So you must keep this in mind, that from radio waves to gamma rays is what? It is from lowest frequency to highest. As you can see, these lines indicate highest frequency, but then the opposite is also true. It is from highest wavelength to lowest wavelength. So it's just the opposite. Yes, radio waves higher wavelength, gamma rays lower wavelength. Radio waves radio waves lower frequency, gamma rays higher frequency. So yes, please keep that in mind. Now we're going to the nature of electromagnetic radiation. So electromagnetic radiation consists of what we call an electrical field and a magnetic field. Yes. So as you can see here, the electric field is the one indicated in red, and the magnetic field is the one indicated in blue. Yes. So electromagnetic radiation exhibits a wave particle duality. Make sure that you befriend yourself with this topic, meaning that the wave can behave as both a wave and a particle. Yes, hopefully that I'm understood. So please keep in mind that the nature of electromagnetic radiation is what it is, a wave particle duality, meaning it can be as both a wave and a particle. With that, I would like to end the lesson. Please stay tuned for more electromagnetic radiation lessons.